at the point O, which is the center, and the point P. Now I want the diameter of the circular patch. The applied potential is 200 volt. Resonant frequency is independent of the resistance of the circuit. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. I have started solving numericals from the model question papers. In my previous session, we have done question paper 1. I hope you people have attended that session, solved the problems again, and you're all geared up for today's session on model question paper 2, the first one. The first problem says, two capacitors. There are two capacitors of capacitance, 600 picofarad and 900 picofarad. Nodi illi capacitance is given in terms of picofarads. So 600 picofarad and 900 picofarad are connected in series. They are connected in series across 200 volt supply. The applied potential is 200 volt. I have to calculate the effective capacitance of the combination. So the two capacitors are connected in series. So first we will calculate the effective capacitance in series. So we know in series the effective capacitance is C1 C2 divided by C1 plus C2, which is the other way of the resistor combination. So CS is 600 into 900 divided by 600 plus 900. So on simplification, the effective capacitance is 360 picofarad. Nodi, just you know the expression for effective capacitance in series, and on simple substitution I have solved the first part of the problem. Next, I will calculate the total charge stored in the system. And if I have studied my theory properly, I understand since two capacitors are connected in series, charge across them should be the same. So here, the charge across each capacitor is same. The reason being they are connected in series. Suppose the capacitors were connected in parallel, voltage across them would have remained same. Now, we all know expression for capacitance is Q divided by V. ನಾನೇನು ಕಂಡುಹಿಡಿಬೇಕಿಲ್ಲಿ? Q. So Q equals C into V. This is the effective capacitance now. 360 into 10 power minus 12. V is 200 volts. On simplification, this turns out to be 72 into 10 power minus 9 coulomb. Again, calculation of charge across each capacitor is done. And I have to calculate the potential difference across each capacitor. So I say V1 is Q by C1. This simplification is an assignment for you all. V2 is Q by C2. Again, substitute. Use your calculators, arrive at the result. The next one, an interesting one. There is a straight wire of length pi by 2. A straight wire, keyword, of length pi by 2, which is bent into a circular shape. Gamansi. Straight wire na ಒಂದು ಸರ್ಕಲ್ ಆಗಿ modify ಮಾಡ್ತಾರೆ. So a straight wire is bent into a circular shape. O is the center of that circle and P is a point on its axis at a distance 3 times the radius from O. P is the point on the axis of the circle at a distance 3 times the radius from O. A current of 1 ampere is passed through it. Calculate the magnitude of the magnetic field at the point O, which is the center, and the point P, which is on the axis. So I have to calculate the magnetic field at the center of the circular coil and at a point on its axis. My dear students, here the entire show gravitates in finding the radius of the wire, for which the hint is the straight wire is bent into a circular shape. Circular shape, circle. What is the area of the circle or circumference? 2 pi r, which should be equal to the length of that circle or straight wire. Circumference of the circle should be equal to the length of the straight wire, or 2 pi r, length is given to be pi by 2. So r is 1 by 4. So very clearly, radius turns out to be 0.25 meter. Notice, simple logically, length of the wire, which is modified as a circle, should be equal to circumference of that circle. So 2 pi r is pi by 2. Length avre kottidare. So r is 0.25 meter. Now I will calculate magnetic field at O, which is the center of the circle. Do I know the expression for magnetic field at the center of a circular coil? Very good. So we know B is mu naught by 4 pi 2 pi IN divided by R. Derive ಮಾಡಿದೀವಲ್ವಾ? Magnetic field at a point on the axis of a circular coil. Adadmele, as a special case, magnetic field at the center of the circular coil. So B is, this is 4 pi into 10 power minus 7, value of mu naught, into 2 into 3.14, radius is 0.25, and on simplification, this is 2.5 into 10 power minus 6 Tesla. ನೋಡಿ ಎಷ್ಟು ಸುಲಭವಾಗಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬಹುದು. Next, magnetic field at the point P, where P is on the axis. So we have here on the axis, again mu naught by 4 pi 2 pi IN R square divided by R square plus X square to the power 3 by 2. Again on substitution, mu naught by 4 pi, 4 pi cancel aito, 10 power minus 7 remains, into 3.14, radius is 2, 25 whole square. R square is again plus. Now the distance of the point from the center is 3 times the radius ಅಂತ ಹೇಳಿದ್ದಾರೆ. Very clearly 3 times the radius. So x is 0.25 into 3. So this is 0.75 whole square to the power 3 by 2. And on simplification, that is 0.079 into 10 power minus 6 Tesla. So again, knowing the expressions, see how easy it is to arrive at the results. The next one, a series LCR circuit is connected to 220 volt AC source of variable frequency. Nodi, alternating current mel problem idu. A 220 volt AC source is connected to some source of variable frequency. The inductance of a coil is 5 Henry and the capacitance of the capacitor is 5 microfarad and resistance is 40 ohms. Now, we got this padana gamanisi illi. At resonance, very clearly, he has told at resonance, calculate first the resonant frequency. Simple agide. So first, ಏನು calculate ಮಾಡೋಣ? Resonant frequency. So resonant frequency is F0 2 pi root LC. Because we clearly know resonant frequency is independent of the resistance of the circuit. So F0 equals 1 by 2 into 3.14. L is 5 Henries into 10 power minus 6. Or F0 on simplification is 31.8 hertz. This simplification, I always leave it for you all because you need to know the mode of substitution and simplification. The next thing I have to calculate is current in the circuit. Now, current in the circuit I, which I call IRMS, as we know, is VRMS by Z. Yen Z andre? Impedance. That means again, I have to calculate the impedance, substitute. It's a tedious job. But when I have studied my theory, I have clearly known that at resonance, Z is equal to R. Nenpitkolli, at resonance, impedance is always equal to the resistance of the circuit. Resistance is very much given. So 40 ohms ಅಂತ ಹೇಳಿದ್ದಾರೆ. So IRMS is 220 by 40. So on simplification, this is 5.5 ampere. No mathematical physics. Simple concepts, calculations are done. And finally, I have to calculate the inductive reactance. What is inductive reactance? It is the opposition offered by the inductor to the flow of AC current. XL and karadvi, which was omega L. What was omega? 2 pi F L 2 into, this is nothing but resonant frequency now. Inductance is 5. So on simplification, this is 998.5 ohms. Done. 5 marker. Without any difficulty, the problem is solved. The next one, problem from optics. This is a very, very beautiful problem. A small bulb is placed at the bottom of a tank containing water to a depth of 1 meter. Picturize ಮಾಡ್ಕೊಳ್ಳೋಣ. So there is a tank, lower surface of the tank, and this is the upper surface of the tank. I place a small bulb at the bottom to a depth of 1 meter. Now, very important. Find the critical angle for water. Critical angle ಕೇಳಿದ್ದಾರೆ. I have to find the critical angle for water and also the diameter of the circular bright patch of light formed. Refractive index of water is 4/3. Andre, it means to say that the light which comes out of this bulb, it is traveling from denser medium to rarer medium. Now, above critical angle, those rays have to suffer total internal reflection. Simple ಆಗಿ ಹೇಳ್ತೀನಿ, ಇಲ್ಲಿ ರೇಸ್ ಆಫ್ ಲೈಟ್ ಇದೆಯಲ್ವಾ, ಅದು ಡೆನ್ಸರ್ ಮೀಡಿಯಂ ಇಂದ ರೇರರ್ ಮೀಡಿಯಂ ಟ್ರಾವೆಲ್ ಆಗ್ತಿದೆ. ಮತ್ತು ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಕ್ರಿಟಿಕಲ್ ಆಂಗಲ್ಕಿಂತ ಜಾಸ್ತಿ ಇದ್ದಾಗ there is total internal reflection. So the rays will suffer total internal reflection, and because of which a circular bright patch is formed. Upper surface alli a circular bright patch is formed. Now I call this the critical angle. This is the radius and this is the height. First critical angle na direct ಆಗಿ ಕಂಡುಹಿಡಿಬಹುದು. Refractive index is given. How do you relate critical angle with refractive index? We know sin C is 1 by n. N is 4 by 3. So sin C is sin inverse 1 by n, which is 1 by 4 by 3. Or when you simplify, that turns out to be 48 degrees 35 minutes. See, first step, critical angle is solved. Now I want the diameter of this circular patch. Radius ಕಂಡುಹಿಡ್ಕೊಂಡ್ರೆ calculation of diameter is very, very simple. So how do I calculate? Now from the diagram, tan C is R divided by H. So tan C is R into H, or R is tan C into H. So this is tan 48 degrees, 48 degrees 35 minutes into H is 1. And on that simplification, 1.13 meter is the radius. So ಈ diagram ಇಂದ tan C calculate ಮಾಡಿದ್ದೀನಿ. R by H. C is 48 degrees 35 minutes, from which R is 1.13. So diameter is 2 times R, 1.13. So the answer will be 2.26 meter. So this is the diameter of that circular patch. The next one, I have already done this as an numerical in the previous session. This will be an assignment for you all. The threshold wavelength of a photosensitive material is 662.5 nanometer. Threshold wavelength ಕೊಟ್ಟಿದ್ದಾರೆ. If this material is irradiated with a radiation of wavelength 331.3 nanometer. Now if radiations of this wavelength falls on the material, find the maximum kinetic energy of the photoelectrons. If the wavelength of the radiation is increased to 496 nanometer, find the change in maximum kinetic energy. Now again, what is the concept I am using? Einstein's photoelectric equation, which says energy of the photon is work function plus maximum kinetic energy. So maximum kinetic energy therefore will be energy of the photon minus work function. So Emax will be wavelength is given minus hc by lambda naught. So this is the concept. I've given you the hint. Use this concept and solve the given problem. So again in this session, students, I have solved problems from model question paper 2. Very much beneficiary because such problems appear in the exam. Next, we solve problems from model question paper 3. Until then, have a nice time. Thank you.